welcome to the Journey Shake Chem. These questions are a little bit of review, so please do the best you can and we'll discuss them in a moment. So please do the best you can and we'll discuss them in a moment. In number 1, we are determining the conjugate base. Well, that indicates that it's Bronsted-Lowry acid-base theory. And the conjugate base comes from the acid. And by this theory, an acid is a proton donor. And therefore, here we have one of these hydrogens that must be donated. And what we are left with is the bisulfate ion. Then in the acetate, the acetic acid, we donate this hydrogen and we're left with the acetate polyatomic ion. Here in the bicarbonate ion, we lose that hydrogen and therefore we are left with the carbonate polyatomic ion. And finally here we have ammonium ion and it gives up a hydrogen and therefore its conjugate base must be the ammonia molecule. And that's how you do number 1. In number 2, we are given a compound, and it is a weak acid. Remember, that's the first thing I ask myself, is it weak or is it strong? Because if it's strong, then I don't go through this process because strong acids have 100% dissociation. And all I would do would be to take the log of the concentration. However, this is a weak acid and therefore I must go through this process. I know that some of it will dissociate, but not all of it. But I don't know exactly how much will dissociate. And therefore, initially, none of it dissociates. And then the change is that some of it will dissociate and I will get X of each one of the particles because it's a one-to-one relationship. Then at equilibrium, I just bring these numbers down and I have 2.5 molar minus X, X and X of these ions. Then I remember that I can eliminate this X because I'm going to assume that it's less than 5% dissociated. Therefore, I'm going to place these X's. X times X would be my X squared divided by my original concentration, and that equals the Ka. And I always write out the equilibrium expression because it's just a good habit to have. Well, then I solve this and I find that X is equal to 7.9056 times 10 to the minus 5th. And then all of these numbers I take to the hundredths place. And therefore I get 7.91 times 10 to the negative 5th molar hydronium ions. Because that's what X represents. Then to get the pH, I just take the log of this number because pH equals the minus the log of the hydronium ion concentration. And when I take the log of this number, I get 4.1020, and then again I take it to the hundredths place. So that equals 4.10 is my pH. Then secondly, I need to figure out how much was dissociated so I can verify that this is indeed true. And I'm going to take the amount that it was dissociated, which is my 7.91 times 10 to the negative 5th, divided by my original amount, which is 2.5 times 100. And I get the amount is tiny, tiny, tiny. It is 0.003164. Now, I take the percentages, or we take the percentages to the tenths place. But obviously we can't do that in this case because it's a 0. So I'm going to go to the first significant digit that I find. And therefore I have 0.003% dissociation. And therefore I was fine with eliminating the X, which is what I want to do so I don't have to do the quadratic. And that's how you do number 2. And on the assessment, you will have 4 of these types of problems to do, and you must show everything. The ice chart, the equilibrium expression, how to solve it, and everything, the equation, all of that must be shown because the problem is worth 10 points. That's 40% of the assessment right there. The remainder of the assessment is the conjugate acids, conjugate bases, the Bronsted-Lowry theory, the Lewis acid-base theory identification. There are some weak, strong, non-electrolyte questions on those, and those should be way easy for you. And then figuring out the pH and figuring out the hydrogen ion concentration, or if you're given hydroxide ions or if you're given hydrogen ions. So that's the format of the assessment that you can expect. I know you do well. You always do well. So I can't wait to see you then. Bye. Thank you.